All right, so you've done all the hard work. You wrestled with the data, you've trained an incredible model, and it actually works, on your own machine. But that brings us to the real question, right? How do you take that brilliant piece of code and turn it into a reliable, automated product that people can actually use? That's the leap we're talking about today, from a simple script to a full-blown system.
And this is the exact spot where so many ML projects just grind to a halt. The model is amazing on your laptop, but what's next? How do you get it out there into the real world? More importantly, how do you make sure you can update it safely, test it like crazy, and know for sure that it's always doing its job? Believe me, these aren't just details. This is everything.
The dream is so simple. A powerful model, just running smoothly in production, doing its thing. But the reality for a lot of teams, it's more like walking a tightrope. Deployments are all done by hand, which makes every update slow and, frankly, kind of terrifying. One little mistake, one wrong click, and the whole thing could come crashing down. It's a process that's just packed with risk.
Let's just call this what it is, the manual deployment trap. It feels faster in the beginning, right? Just copy some files over, restart a server. But what you don't see are all the hidden dangers that are slowly creeping in, ready to undermine your entire ML system.
And this is where that pain really starts to show. When you deploy by hand, you're going to get human error. It's inevitable. And because nothing is automated, you have no reproducibility. So when something breaks, good luck debugging that. It's a nightmare. This leads to these super long, stressful deployment cycles, which means you can't experiment or improve things quickly. It's this vicious cycle where every manual step just creates a new way for things to fail, and you're left with absolutely no safety net.
So here's the bottom line. When you build ML systems manually, you're building something that is fundamentally fragile, incredibly slow, and totally unreliable. It's just not a sustainable way to work.
But, thankfully, there is a much, much better way. The solution that powers all modern, scalable ML operations is CI/CD. This is how the pros escape that manual trap. It's how they build systems that are tough, automated, and actually ready for the real world.
So what in the world is CI/CD? Well, it stands for continuous integration and continuous deployment. And the easiest way to think about it is like an automated assembly line for your model. It takes care of everything for you, testing your code, packaging the model, stamping it with a version, and shipping it out, all without a human having to touch a thing. It's all about making the entire process rock solid and repeatable, every single time.
Okay, enough theory. Let's get practical and see how this thing actually works. We're going to look at how you build the pipeline step by step and see how it turns that manual chaos into beautiful automated harmony.
A typical pipeline has 4 main stages. It all kicks off the second a developer commits some new code. Instantly, a whole bunch of automated tests start running, checking the code, the data, even the model logic. If all those tests pass, the system automatically starts building and training the new model. And then, finally, if that's successful, it gets deployed. All automated, all consistent, no drama.
Now, this automation isn't some kind of black magic. It's just defined in code. It looks a little different depending on the tool, but usually it's just a simple configuration file, kind of like this example from GitHub Actions. You're basically just writing down the recipe for the system to follow.
And this little piece of text right here is where the magic happens. This tiny line, on, push, that's the trigger. It means that every single time a developer pushes new code to the repository, that entire automated workflow we just talked about kicks off. No buttons to click, no commands to run, it just works.
So that one little line kicks off a series of really important jobs. First, it sets up a perfectly clean and consistent environment, every single time. Then, it runs all your tests to catch any bugs nice and early. After that, it executes your script to train the model. And finally, and this part is absolutely critical, it logs that brand new model into a registry with a unique version. That way, you always know exactly what is running in production.
Okay, now let's talk about one of the coolest, most powerful features of using CI/CD for machine learning. You see this number up here, 85% accuracy? And you might be wondering, what does a performance metric have to do with an automation pipeline? Well, it turns out this is a total game changer.
The answer is so simple, but so powerful. It acts as an automated quality gate. You can literally tell your pipeline, hey, do not deploy any new model unless its accuracy is at least 85%. So if a new version gets trained and it doesn't meet that bar, the pipeline just fails. Automatically, it stops a bad model from ever even getting close to your users.
So your model has passed all the tests, it's hit your quality bar, and it's ready for deployment.
but we're not just going to flip a switch and pray, right? No, automation lets us use much smarter, much safer strategies for rolling out new models.
This is where automation really starts to flex its muscles. Instead of a risky all-or-nothing release, you can do things like a canary deployment, where you release the new model to just a tiny fraction of your users first to see how it does. Or you can do A/B testing to scientifically compare two models in the wild. And one of my favorites, shadow testing, where you run the new model silently in the background, feeding it real traffic so you can see how it performs without a single user being affected. These professional techniques are only really possible with a solid automation pipeline.
Now, it's important to remember that building these pipelines isn't about finding one magical tool. It's really an ecosystem. You've got different categories of tools that all have to work together. You need something for versioning your code and data, a CI/CD engine to run the automation, containers like Docker to keep everything consistent, a model registry for tracking, and of course the infrastructure to run it all. They're all pieces of the same puzzle.
Okay, so as we start to wrap this up, let's distill everything we've talked about into a really clear set of best practices, the things that will help you truly transform that model of yours into a real product.
All right, let's lock in the key takeaways. Number 1, do treat your ML project with the same discipline as a software engineering project. Do use a model registry to keep a perfect history of every version you've ever built. Do use containers like Docker to kill the whole "it works on my machine" problem forever. And you absolutely have to automate your retraining pipelines and always have a rollback strategy ready to go. This stuff isn't just nice to have, it's about being a professional.
And just as important are the traps you need to avoid. Please, never ever deploy manually. Don't think for a second you can get away without version control. And whatever you do, do not use a Jupyter notebook for anything other than exploration. It is not a production tool. Don't forget to validate your data, because garbage in, garbage out. And finally, don't fly blind. You have to monitor and log what your models are doing in production. Avoiding these mistakes is half the battle.
So if you take away just one thing from all of this, let it be this simple, powerful idea. CI/CD is the engine that transforms machine learning. It takes you from having an experimental, fragile model and gives you a reliable, scalable, and genuinely valuable product. It's not just about automation, folks. It's about professionalism.